And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and today we'll be talking about how there still is a significant chance of Geoeffective coronal mass ejection. A couple of large earthquakes that happened yesterday. One of them just before midnight. No tsunamis that we know of at this point. First thing we're doing is looking at the sun. Here it is in colorized magnetogram from the SDO, the Solar Dynamics Observatory. Quick breakdown. This is not a sunspot. These are sunspots, barely. And this is a sunspot. Otherwise, not a lot of activity. And as we've shown many, many times on the channel, we don't need a lot of activity to see coronal mass ejections. There is a lot of plasma in between the Earth and the Sun right now, and it could eject with absolutely no warning. Part of the reason we have a channel is to provide one occasionally. Who knew we'd be in the position we're in? Here's the sun once again in colorized magnetogram along with 171 angstroms. And you can see that sunspot is in the Earth-facing zone, which actually lowers the likelihood of large solar flares from that particular group. I would invite all of our viewers to follow me on Twitter. If you haven't followed me on Twitter yet, you may not have checked out this poll. We are interested to know what you think the biggest fraud in 2020 was. Was it that masks/lockdowns work? Was it that your vote counts? Was it that Fauci committed fraud about herd immunity? Was that the largest fraud of 2020? Or was the largest fraud of 2020 the COVID-19 mortality rate? What say you? There's another 4 days left to participate in that poll, and it is the biggest poll that our Twitter page has ever had. We've already got considerable responses. And when it comes to that poll, your vote definitely counts. And let's talk about the most hilarious quote that I've heard so far today. This one coming from our pal Diamond over at Oppenheimer Ranch Project. The quote is, "In order to watch cosmic rays, you just need to watch the real-time solar wind." A great quote from Diamond. If you haven't watched his Diamond Saturday Night Live broadcast, perhaps check it out. Here's a clip.
I can't even figure it out. This is so not interactive. Pop out chats, toggle timestamps.
Anyway, Diamond's been a contributor on our channel many times. Thanks for all the shout-outs, Diamond. And again, go check out his Diamond Saturday Night Live episode if you like. The 10.7 centimeter radio flux, getting back to some data about solar wind and so on. This isn't solar wind at all. This is electromagnetic radiation coming out of the sun's outer corona in the realm of 2,800 megahertz, 2,800 megahertz, or 10.7 centimeters. Anyway, the radio flux is at 78. There's the one-year chart to put that in context. Here is the chart of the last cycle's sunspot number progression, as well as the beginning of this cycle. Welcome to cycle 25. Welcome to the DL Renaissance, and so on. There is the radio flux, and you can see how proportional that is to sunspot number. Next, taking a look at the view from Lagrange point 5 here at stereo A. And I just wanted to show this again because this was good enough to feature on yesterday's thumbnail. We do have some missing data here, which is a little bit perplexing. I'll bring that up first. So here's the difference data if you look at just after midnight. 0 dark 54:24. So 54 minutes after midnight and 24 seconds we saw this happen. A loss of a couple of hours of data. Not a fan of that, but it is still quite the difference image. Allow me to vanish. And yeah, that was good enough to be featured on yesterday's thumbnail. So yeah. And that's yet another reason to subscribe to the channel, because our thumbnails often contain information not in the videos. So if you weren't aware, here's the raw data from stereo A. And the difference data is just the raw data subtracted from the previous raw data. That's why we call it the difference, because it requires data subtraction. So let's get on to some more stuff here. Here is the position of stars, of planets rather, in the local solar system. One star, otherwise known as Sol. There's where things will be in a week on January 31st. And we've got some spectacular helioviewer movies once again. Here's the magnetogram animated over the past 24 hours. And you can see all of the sunspots remain pretty stable here. They're all alpha class now, and likelihood of significant solar flares has dropped, unlike the likelihood of coronal mass ejections, and indeed, once again, to reiterate, geoeffective ones. There is a large portion of plasma in between Earth and Sun, and that large bright object you see over there on the left, that's actually Jupiter. (304 angstroms plus the LASCO C3). This is actually sort of an ongoing coronal mass ejection scenario here, which is mostly producing ejecta that's expected to miss the Earth to the north and west. Here's a little closer image as we zoom in a little closer. And let's get a little closer than that and show a little more additional detail. So not quite as exciting as yesterday's plasma extravaganza. If you didn't watch yesterday's video, check that out. That would be on YouTube as well as on BitChute and posted to all of our social media accounts. Some fantastic fireworks coming out yesterday. Here's a 94 angstroms view, and we're going to save the rest of the images of the local yellow dwarf for the end of the video, after we go through the rest of the data and do a short cosmology segment. That B-class flare that happened there just before midnight was actually pretty long-lived. And our close-ups should be pretty good. Did you watch yesterday's Smash Lights segment? We did a live stream. I think it was about 40 minutes long. You can find that in our playlists at youtube.com/smashomash/playlists. Let's go over volcanoes. Klyuchevskoy is erupting, producing a 28,000-foot ash plume. Shivaluch, also on the Kamchatka Peninsula, 17,000-foot ash plume there, otherwise known as flight level 170. Flight level 040 over Suwanose-jima, it's a 4,000-foot ash plume. Popocatépetl, down in central Mexico, exploding, 19,000-foot ash plume over that caldera. Sangay exploding, 22,000-foot ash plume. And continuous emissions from Sabancaya are a reminder to not attempt to pole vault any volcanic calderae. So we saw a couple of 7 magnitude quakes here. Originally reported as 7.3s, now downgraded to a 6.9. And that's all one quake there, folks. Those are just, this is tsunami.gov. This is just to show the initial reporting list. Here's the location of that one. It happened very far south, right near the Drake Passage, actually, near the Antarctican continent. And an odd place for a quake there. No tsunami warnings, watches, or advisories issued as a result of that. Let's go back the past 24 hours here and see what else was shaken, and some deep quakes indeed were, such as this 4.8 at the Fiji Islands. That was at 519 kilometers depth. And that was about 40 minutes after this 5.5 struck at Papua New Guinea. What else do we have? What else do we have? Small deep quake at Alaska. Another small deep quake at Alaska, and there's that now reported as 6.9. A downgraded earthquake near the South Shetland Islands. We also saw a significant deep quake here on the west coast of South America once again. This 110 kilometer deep 5.8 magnitude. Right in the middle of the Andes. Anyway, there's the location of that in Argentina, Chile. And I've just shattered my browser by closing the entire thing and completely messing up the stream. So for that, I apologize. I think I pressed the wrong series of buttons. Let's bring that back up and get going once again. I apologize. And that is the danger of doing a live stream, folks. Don't worry, there's plenty of things that I can talk about in the interim. For example, please don't forget to press like and subscribe, because, as you can see, the place is burning. Burning to the ground, burning. And we need your assistance to get the information out there to our viewers. So let's get back to data. We're going to do the real-time solar wind next. And allow me to put this out. Ah, that's better. Ah, the temperature. It's not so globally warm in here anymore. And thanks for leaving a comment, precious slights. Next, we're looking at the real-time solar wind, which is fully drawn in today. And for that, we thank you. Let me make sure I've got it on screen. And we really do see the BTBZ all over the place here over the past 7 days. Some significant shifts in the BTBZ. Phi angle has been fairly steady over the past couple of days here. This is a 7-day chart. We don't always show the 7-day chart, but today we did. So current solar wind conditions are about 6 protons per cubic centimeter for the density and the speed about 351 kilometers a second. It looks like we just saw a pretty weak coronal hole wind stream strike here in the past 24 as I forecasted. And there you can see it only made it up to about 384 kilometers a second. The density did briefly make it up to a little over 20 protons per cubic centimeter. And we can see this looks like it's dying down here as we see the temperature dropping, a typical signature of a coronal hole wind stream. Here is the KP index currently at 2 for the past 6 hours. And you may see some loading here. I apologize. Again, I closed the entire browser by pressing Alt F4 instead of Control F4 to close a tab. Cheers. So here's 4 hours of data on magnetohydrodynamic pressure. And as you can see, pretty steady here over the past 4 hours. We show it daily because you can't access the archival data. Here is the ground magnetic perturbation maps. And we'd like to show changes in the B field daily since we are living through a polar excursion, a geomagnetic excursion, folks. We've got 2 north poles. We've got a south pole that's left the Antarctic continent, thousands of miles from the geographic South Pole, now in the southern Indian Ocean, someplace south of Australia. Anyway, that's 4 hours of data on changes in the Earth's B field, or geospace delta B. Let's talk cosmology for a quick, brief moment. We're going to roll a quantum die and come up with a number of 141, which coincides with an object at the Neil Gorell Swift Bat X-ray Observatory. So 141 is our quantum number, which coincides with AT 2019 way. AT 2019 way, which is a null object. An X-ray source that we, frankly, have no idea what is up with it. AT 2019 way. All right, that's one of the weirder cosmic objects. Let's see if I can do a search and figure out what that is. More of the dangers of streaming live. So it's a multi-wavelength emission source. Is it an alien colony? Is it an extraterrestrial life form? Perhaps it's a cloud of BS on a YouTube channel. Who knows? Here's an article about its X-ray brightening. And I have no idea what that is, as that's a language I don't read or write. Anyway, here are some multi-wavelength observations. It's a 22-page article. Can we get to it? Anyway, perhaps we'll save that for a later video. It's the daily space weather. We don't want it to be too lengthy. And that's today's cosmology segment. Let's continue on. To remind our viewers that big tech cannot break the internet. However, the internet can break big tech. And if I had to amend that nowadays, I would add Amazon to the list. Google, Facebook, Amazon, Apple, and Twitter can't break the internet, but the internet can break them. Are you enjoying the self-destruction of big tech? If so, perhaps pick up one of our Google-defined t-shirts. I've got one of these on the way myself. It's in the color red. It's not because of political affiliation. It's simply because I don't have enough red shirts. If you're not familiar with the definition, I'll let it scroll. Perhaps pause the screen to understand the definition of the term Google when used as a verb. Here it is in a sentence. I Googled it, and now I know less about it. We are streaming live to Twitch, by the way. And while we do stream live to the YouTube platform on the regs, this one is currently exclusively available on Twitch, twitch.tv/smAsho. They've got a great mobile app as well. Perhaps check that out. You'll get notifications when we do videos. If you're watching the video on YouTube, thanks for viewing the live premiere, and thanks for viewing in whatever context. Please tell your friends and foes, press share, press like and subscribe, press the notification bell, etc. Check out our links. Check out our merch. It's pretty sweet. Check out our own webpage, smAshomash.com. Again, cheers to our YouTube viewers. We are also on BitChute, and our subscribers keep going up over there. Excellent, excellent. Thanks to our BitChute viewers and to our YouTube viewers. If you're not subscribed over at BitChute, get subscribed. And while we thank the Smash team for being subscribed wherever you happen to be, there's exclusive content on all of the different social media networks. So you're missing out on something if you're not involved with all of them. So, and of course, look for the entire web ring to expand soon. We are now branching out into the realm of web hosting, website design, corporate branding, and so on. If you need a website, drop us a line. You can find all kinds of information on how to contact us below the video, as well as on our own website, smAshomash.com. If you need a website built, corporate branding, graphic design work done, hit me up, and we'll talk all about it. And thanks for being a part of the Smash team. And please leave a comment also. We're always interested in what our viewers have to say. We read all comments thanks to our patrons, the true source of funding for the content. Please consider funding us at patreon.com/smAshomash. You're probably well aware that there are no guarantees when it comes to the realm of YouTube, and we certainly do not anticipate being paid ever, although we are paid minimally from YouTube for the content. The main funding comes from our patrons. Again, patreon.com/smAshomash. Additional benefits there as well. If you haven't seen our Smash Holes of the Week segments, well, there's another one coming out very soon, perhaps today. It'll be about fascists, and I'm sure you all know all about that overused word. Congratulations to everybody for surviving a global pandemic so far. Let's get back to some more science data. Didn't mean to get sidetracked there. Now, the GOES-16 makes its measurements at the Ionosphere layer, so we show this diagram daily, so folks have some idea of where the GOES-16 is measuring things. This also shows you the penetration of electromagnetic radiation into the atmosphere, and you can see there visible light and infrared light are the main radiation to make it all the way to the troposphere, which is the part of the atmosphere in which you live, where all your weather occurs. And there you can see that solar flare happening just before midnight at 2340 Universal Time. That solar flare began, and it lasted a solid 20 minutes before it slowly ramped down. That's not a major solar flare. It's a little brightening, and it's from sunspot 2798, I believe is where that one came from. There's been no geoeffective plasma, significant coronal mass ejection strikes, and there you can see the proton flux has been flatlined. The GOES magnetometer still looking a little spiky here as the Earth is about to switch polarity current sheets. The Earth is about to move into the North Pole current sheet unless something suddenly changes magnetically speaking, and don't be surprised if it does, because it can. So here's the top view ecliptic plane field plot. And you can see the Earth about to move into a North Pole current sheet shown there in green. Here's the last image. We'll stop it on that point. There's the last image. And by tomorrow's daily space weather video, we expect to be well into the North Pole oriented current sheet. Here's a coronal hole field plot from a line of sight perspective instead of from a top view, since you live on the ecliptic plane. It looks like some additional coronal holes about to rotate in. Here's another view of the line of sight. It also shows you the solar magnetogram and the poloidal fields. Next, we'll show the coronal magnetic field plot, the field plot of the solar corona, the sun's atmosphere. And I just want to make sure we have the latest data here, so we'll bring that back up. Not a whole lot to comment on there. It's a chaotic place, the solar atmosphere. A little more chaotic than the Earth's atmosphere, you could probably say. Next, looking at the Ionosphere map. Just give that a minute to load. Again, I did close my browser down like a complete doofus. So give that a minute to load here. It's from the Australian Government Bureau of Meteorology. That'll show you a whole day of data. And those different color blobs are frequencies of vibration in the ionosphere. And where you see the red blobs, that's the F layer. Yellow would be F2, olive would be F3, and so on, as multiple layers are created. Multiple frequency layers. Anyway, here's the latest image. That's from 12 o'clock Universal Time. Pardon the lateness. And I was off a little bit with the forecast. I forecasted for the electron flux to be down here, and it's way up there. I was off by like 150 pulse flux units. I'll take my demerits a little later. Here's the total electron content forecast. This will show you where GPS errors are likely to occur. And the darker the blue, the less likely to see a GPS error in your location. And of course, the most common spots for those would be around the equator during local summertime at noon, for example. And we see a pretty we show this one daily because it's useful data. It's showing basically the inner Van Allen belt. Excuse me. And here's a 3-day chart of the GOES electron flux as measured by the GOES-16 at about 300 kilometers of altitude. There's the 1-year chart of the electron flux, and you can see we're at very low levels here. And surprisingly, the coronal hole wind stream, well, not really that surprising because it was pretty weak. It didn't really cause that big of a downtick in the electron flux there, as you can see. Not at the lowest levels we've seen, but pretty low. Next, looking at some meteorological stuff. Here are the jet streams of the Western world. Massive anticyclone at the jet stream scale in between Greenland and Canada. You can see that clockwise rotation there, as well as a big bend here over South America. Next, we'll look at the jet streams of the Eastern world. By the way, this is on nullschool.net. We had a viewer yesterday ask where this is. Nullschool.net. And the 250 hectopascal winds would probably be the most significant piece of weather data if you had to look at only one piece of weather data for the whole planet, I would say. It's a certain band of pressure that shows you where jet streams are located, and here in the eastern portion of the planet, you can see the jet streams are blowing backwards over the Western Pacific and Indian Oceans. You see these blowing in a westerly direction from east to west. Next, we're going to show you a snow depth forecast here on windy.com, just for the U.S. Sorry, lower 48 only. Here's where snow is now. And there's where snow is expected to be at 1 p.m. tomorrow, as we saw a little bit of snow falling around. It looks like the Great Lakes region, but not a significant amount of accumulation going to happen there. The main accumulation will be, it looks like, Kansas and Nebraska. Over the next, say, 30 hours. Anyway, that's the European forecast for snow, courtesy windy.com, who's got a great mobile app as well, by the way. Next, we'll look at the GOES Lightning Mapper. It's the GOES 16 Lightning Mapper, and there's not a lot of lightning to really map, so let's move on to the real-time lightning map at lightningmaps.org, where you could convince your friends and foes that you're Thor or perhaps Odin, and that you've revoked your lightning from Zeus. Please leave a comment if you're Zeus's boss. And we see some lightning in the Atlantic and Pacific, otherwise not a lot. Next, we'll look at the U.S. Doppler radar map. Some heavy stuff falling in southern Indiana there. Probably heavy snow as well as some wintry mix about to move in. Let's hope it doesn't get too icy. And I wonder if we've got any power outages. We'll ignore that for today and just show the water vapor map for the Americas. There is the water vapor situation at the American GOES Interactive Weather Satellite Station. Next, we'll look at the cloud layer. And again, I apologize. I had to restart the browser here as I experienced a senior moment, or you could say technical difficulties. Check out all the low clouds over the Atlantic Ocean. And there's the water vapor map of the same area. There's the cloud layer. There's the water vapor. And thanks again, Smash Team, for tuning in. We've got bonus features, such as a clip from Eugene Bagashov's latest video. No idea. Methods of Theseus and Ulysses. And this is very useful in that these are two very different schools of thought. One is that you have to go from point A to point B to point C to point D to reach point E. And the other one is to reach point E, you go on whatever route you possibly can. So that's got a lot to do with our daily space weather videos, actually, because we've heard all kinds of different theories about the mechanisms that cause stars to do what they do, and so on. And so that's part of the reason why we make the daily space weather videos, because we're looking deep into the data every day to see what the connections are and indeed aren't. So perhaps check this one out. It's about an hour and 13 minutes long, about the methods of Theseus and Ulysses. Here's a short clip.
Yeah, if it leads us to where we want to go, it's that kind of situation out there.
So check out that video. It's basically about the scientific method and so on. Methods of Theseus and Ulysses. And make sure you give Eugene the Philosopher a subscribe. He's a regular contributor over here at the Smash News Network. Also, please press like and subscribe on YouTube. I implore you. And thanks for leaving a comment, Tara Nicole Smith 230. Thanks for shouting out from North Carolina. We're located here in Lehigh Valley, Pennsylvania. Again, if you're viewing on YouTube, BitChute, etc., leave us a comment, press share, press notification bell. We've got bonus features in the form of the solar intensity gram to show you the current high-res images of the local yellow dwarf. Here is the intensity gram of sunspot 2797, and it looks like 2798 is gone entirely. So here's 2797, folks. It's been downgraded to alpha class, 2798 gone entirely, and here's 2799. We'll scroll over to it. 2799 also now alpha class. There's that little dimple. Here it is in colorized magnetogram. So pretty weak solar activity. Don't let that rule out the possibility of coronal mass ejections, folks, because it doesn't at all rule out the possibility of coronal mass ejections. Let's get back to our close-up images of the local yellow dwarf. I think we left off at 94 angstroms. We'll get back to it. There you go. And here's me vanishing. You can see that solar flare there at 94 angstroms pretty well. We'll make sure these are on loop. There you can see that B-class solar flare coming out of sunspot 2797, I think it is. I think that came out of 2797. Not exactly sure, but who really cares? Here's 193 angstroms. Great view of that coronal hole in the southern latitudes. And our close-ups today are a different wavelength than we've ever used before. This is a combination of 335 and 171 angstroms. This was kind of custom. So there's that. Great view of the southern hemisphere. And maybe we'll put out a smAshomash.org presents the sun video today. Here's this active region as well as a filament up here where my pointer is. Again, that's not a sunspot. And here's sunspot 2799 as it's getting close to setting over the northwestern solar horizon. Thanks for tuning in, folks. Remember, stare at the sun, don't drink, and if you do, don't drive. Welcome to the Neo Renaissance. Visit our links, buy our merch, become a patron. And since it'll never be now again, may that solar wind be at your back.